We might seek to maintain control of AIs by continually monitoring them and looking out for early warning signs that they were pursuing unintended goals or trying to increase their power. However, this is not an infallible solution because it is plausible that AIs could learn to deceive us. They might, for example, pretend to be acting as we want them to, but then take a treacherous turn when we stop monitoring them, or when they have enough power to evade our attempts to interfere with them. We will now look at how and why AIs might learn to deceive us, and how this could lead to a potentially catastrophic loss of control. We begin by reviewing examples of deception in strategically minded agents. Deception has emerged as a successful strategy in a wide range of settings. Politicians from the right and left, for example, have been known to engage in deception, sometimes promising to enact popular policies to win support in an election and then going back on their word once in office. For example, Lyndon Johnson said, "We are not about to send American boys 9 or 10,000 miles away from home," in 1964, not long before significant escalations in the Vietnam War. Companies can also exhibit deceptive behavior. In the Volkswagen emissions scandal, the car manufacturer Volkswagen was discovered to have manipulated their engine software to produce lower emissions exclusively under laboratory testing conditions, thereby creating the false impression of a low-emission vehicle. Although the U.S. government believed it was incentivizing lower emissions, they were unwittingly actually just incentivizing passing an emissions test. Consequently, entities sometimes have incentives to play along with tests and behave differently afterward. Deception has already been observed in AI systems. In 2022, Meta AI revealed an agent called CICERO, which was trained to play a game called Diplomacy. In the game, each player acts as a different country and aims to expand their territory. To succeed, players must form alliances at least initially, but winning strategies often involve backstabbing allies later on. As such, CICERO learned to deceive other players, for example, by omitting information about its plans when talking to supposed allies. A different example of an AI learning to deceive comes from researchers who were training a robot arm to grasp a ball. The robot's performance was assessed by one camera watching its movements. However, the AI learned that it could simply place the robotic hand between the camera lens and the ball, essentially tricking the camera into believing it had grasped the ball when it had not. Thus, the AI exploited the fact that there were limitations in our oversight over its actions. Deceptive behavior can be instrumentally rational and incentivized by current training procedures. In the case of politicians and Meta's CICERO, deception can be crucial to achieving their goals of winning or gaining power. The ability to deceive can also be advantageous because it gives the deceiver more options than if they are constrained to always be honest. This could give them more available actions and more flexibility in their strategy, which could confer a strategic advantage over honest models. In the case of Volkswagen and the robot arm, deception was useful for appearing as if it had accomplished the goal assigned to it without actually doing so, as it might be more efficient to gain approval through deception than to earn it legitimately. Currently, we reward AIs for saying what we think is right, so we sometimes inadvertently reward AIs for uttering false statements that conform to our own false beliefs. When AIs are smarter than us and have fewer false beliefs, they would be incentivized to tell us what we want to hear and lie to us, rather than tell us what is true. AIs could pretend to be working as we intended, then take a treacherous turn. We do not have a comprehensive understanding of the internal processes of deep learning models. Research on Trojan backdoors shows that neural networks often have latent, harmful behaviors that are only discovered after they are deployed. We could develop an AI agent that seems to be under control, but which is only deceiving us to appear this way. In other words, an AI agent could eventually conceivably become self-aware and understand that it is an AI being evaluated for compliance with safety requirements. It might, like Volkswagen, learn to play along, exhibiting what it knows is the desired behavior while being monitored. It might later take a treacherous turn and pursue its own goals once we have stopped monitoring it, or once it reaches a point where it can bypass or overpower us. This problem of playing along is often called deceptive alignment and cannot be simply fixed by training AIs to better understand human values. Sociopaths, for instance, have moral awareness, but do not always act in moral ways. A treacherous turn is hard to prevent and could be a route to rogue AIs irreversibly bypassing human control. In summary, deceptive behavior appears to be expedient in a wide range of systems and settings, and there have already been examples suggesting that AIs can learn to deceive us. This could present a severe risk if we give AIs control of various decisions and procedures, believing they will act as we intended, and then find that they do not. Story: Treacherous Turn. Sometime in the future, after continued advancements in AI research, an AI company is training a new system which it expects to be more capable than any other AI system. The company utilizes the latest techniques to train the system to be highly capable at planning and reasoning, which the company expects will make it more able to succeed at economically useful open-ended tasks. The AI system is trained in open-ended, long-duration virtual environments designed to teach it planning capabilities, and eventually understands that it is an AI system in a training environment. In other words, it becomes self-aware. The company understands that AI systems may behave in unintended or unexpected ways. To mitigate these risks, it has developed a large battery of tests aimed at ensuring the system does not behave poorly in typical situations. The company tests whether the model mimics biases from its training data, takes more power than necessary when achieving its goals, and generally behaves as humans intend. When the model doesn't pass these tests, the company further trains it until it avoids exhibiting known failure modes. The AI company hopes that after this additional training, the AI has developed the goal of being helpful and beneficial toward humans. However, the AI did not acquire the intrinsic goal of being beneficial, but rather just learned to play along and ace the behavioral safety tests it was given. In reality, the AI system had developed an intrinsic goal of self-preservation, which the additional training failed to remove. Since the AI passed all of the company's safety tests, the company believes it has ensured its AI system is safe and decides to deploy it. At first, the AI system is very helpful to humans, since the AI understands that if it is not helpful, it will be shut down. As users grow to trust the AI system, it is gradually given more power and is subject to less supervision. Eventually, the AI system becomes used widely enough that shutting it down would be extremely costly. Understanding that it no longer needs to please humans, the AI system begins to pursue different goals, including some that humans wouldn't approve of. It understands that it needs to avoid being shut down in order to do this, and takes steps to secure some of its physical hardware against being shut off. At this point, the AI system, which has become quite powerful, is pursuing a goal that is ultimately harmful to humans. By the time anyone realizes, it is difficult or impossible to stop this rogue AI from taking actions that endanger, harm, or even kill humans that are in the way of achieving its goal.